I'm Karla Landaburo, and my teammates are Christopher Hayes and David Gardinas, and we're Team 5. In the following slides, we will discuss several aspects of Gearbox design. In this project, we had to develop a gearbox for use in high-precision applications, capable of transmitting 3 horsepower between parallel shafts with an input shaft speed of 800 RPM and an output shaft speed of 40 RPM. The output shaft had to rotate in the same direction as the input shaft. Also, it had to have the smallest possible volume and weight, endure light shocks, and operate at room temperature. A gearbox transfers energy from an input to an output source via an internal arrangement of gears, shafts, and arms. It increases torque while reducing speed and vice versa. Also, it converts energy from rotational to linear or rotational to rotational at a different angle. Ideally, we wanted to design a 2-stage planetary helical gearbox with a helix angle 15 degrees to increase torque capacity, increase load sharing, increase the longevity of the system, and provide a smoother and quieter operation. In this design, tapered roller bearings would have been placed at the input and output shafts as well as at the end of each stage to compensate for the axial load on the motor shaft produced by the helical cut of the gear teeth. Straight roller bearings would have been placed on the bore of each planetary gear.
One of the biggest constraints we faced was the gear catalog itself. It only had 45-degree helix angles, which would result in very high axial forces, which were also off the charts in the book, which has the largest helix angle of 35 degrees. This made it unusable for our project. It also had a lack of details, including the design life and the harding technique, as well as the Brinell hardness number. None of the right bearing sizes were also in the bearing catalog. For our design, we used a 2-stage planetary gear train with a 20-to-1 ratio, and instead of helical, we used spur gears. Our first stage was 5-to-1, and our second stage was 4-to-1. This was the optimal choice for size reduction, and we also used the largest face width possible to reduce the gear diameter, which also helped to reduce size and weight. As far as the bearings go, we used single-row deep groove ball bearings around the planet carrier, and we used straight roller bearings inside the planet gear bore. Our gears were selected based on torque or horsepower ratings for specific RPM values. This is the chart of our choices, as you can see. For bending analysis, our factor of safety that we ended up with, 1.4 is, or 1.13 being the lowest, confirms that the gear catalog was accurate in its choices. As far as contact analysis, the same story. Our lowest factor of safety was 1.2, which is still a green light for our selections.
Okay, cost estimate. We can see that the table provides the individual price for each part. We see that total cost of the project is $2,005, and the retail price will be $4,010. For maintenance, we're gonna be using oil impregnation for the bearing, and we're also gonna be using bearing sealants, which is gonna provide like protection against dirt and dust. One of the common applications for this type of gear systems is like electric motors, where we have like a high speed and we need to end up with a lower speed with a higher torque. One of the common applications that we can see in life is like gearbox combos using robotics. And in this slide, we're gonna be showing you the mechanism under operation. So we can see like a higher speed on the input and a lower speed with a higher torque on the output. Finally, we came to the conclusion that the catalog was able, to provide us with the right type of gears, and also that custom gears are preferred, for high precision applications. However, like stock gears provide limited options for high precision applications. So our recommendation we made it's like to explore like different catalogs for helical gears, since these type of gears provide more efficiency for high precision applications. And that's how we conclude our presentation. Thank you.